These are scenes of avoidable and expensive disasters. Did they occur due to bad design, inadequate maintenance, or incorrect operational procedures? Experience shows that a large number of machinery breakdowns occur due to a mistake in operation or maintenance of the alarm systems and the protection devices. Yes, engines, generators, boilers, compressors do break down, sometimes fatally damaged because the alarm systems and the protection devices monitoring them have been prevented from working. Sometimes deliberately disconnected, sometimes clogged up with paint and forgotten, abandoned without checking for long periods of time. This, of course, is asking for trouble, when only a little attention to detail by duty engineers could avoid an unforeseen incident, resulting in possible injuries of people, major machine breakdowns, upsetting the commercial operation of the vessel, leading to extra workload for ship's personnel. Once a less than meticulous checking and maintenance regime of the alarm systems is allowed to develop on board ship, things can go wrong at any time. The ship's systems cease to be reliable because no one can be sure which alarm is working and which is not. Now what? A blackout. This can occur as a direct consequence of neglecting the alarm system and protection devices. Now the search begins. What caused the blackout? How long will it take to get things going again? Why isn't the standby generator or the emergency generator starting? How long will it take to find the answer? An unscheduled event like this can cause consequential breakdowns as well. Let's hope it's not too bad. Unfortunately, a ship cannot run on the basis of hope alone. The engineers on board ship must be sure that the alarm systems work properly at all times. There is no other way. Let's leave this nightmare scenario now and look at a typical schematic view of an alarm and protection system and its function. A typical alarm circuit has a sensoring device, such as a level sensor, a thermocouple, or a pressure sensor. These are normally connected to display devices, which may have minimum and maximum values marked on them. When these values are reached, a switch is activated and an electrical or pressure signal is sent to the ship's alarm panels and audio-visual warning devices. The light on the panels will remain on or continue flashing until the alarm has been acknowledged by the duty engineer and the condition which has caused the alarm to activate is removed. If it is a protection circuit as well as a warning circuit, the activation of the limit switch also initiates a shutdown procedure of the affected machines. That is, the protection circuit activates one or more switches or valves, causing the protected machine to come to an unscheduled halt, but in a controlled manner. This is how the system looks using internationally recognized symbols. A typical example of this system operates on a main engine or on a generator diesel. The sensor may be a lube oil temperature or pressure sensor, or cylinder liner temperature sensor. Any one of these may indicate a loss of adequate lubrication, which requires rapid reaction to avoid a serious engine breakdown. With hundreds of installations in the engine room, the alarm systems and protection circuits there form a complex loom of monitoring systems. There are some vital protection devices, as well as some less important circuits. Do you know which circuits on your ship are very important and which are less so? If you came across a faulty sensor, would you know if it was part of a top priority circuit or a relatively less critical one? You need to know. All alarm and protection devices which protect the main propulsion engine and the steering system are of top priority, as are those on the power generation plant and steam boilers. These plants are vital components of ship's control. Any breakdown or serious loss of these functions can be catastrophic for the ship and its crew. Still very important, but not top priority, are the alarms and protection devices monitoring the air compressors, air conditioning systems, and refrigeration systems. They may not be as critical in the North Sea as they are in the Gulf. Other systems, such as cargo pump alarms or bow thruster alarms, may be low or high priority depending on the ship's working condition. There are warning-only alarm systems, which do not protect but warn of potentially hazardous conditions arising. These are normally level indicators or temperature sensors in tanks and heating or cooling systems. Now let's look at sensors, starting with level indicators. These monitor liquid levels in fuel tanks, lube oil tanks, boilers and the like. The simplest systems are activated by the liquid itself. The device is activated by the level of the fuel rising or sinking above or below the set safety levels. When this occurs, a sensor sends a signal to the warning devices, coupled usually with an indicator. One of the most important level alarms on board ship monitors the boiler water level. It is critical to maintain the right water level in boilers, especially in high-pressure water tube boilers, to ensure safe operation. A very dangerous situation can rapidly arise if the water quantity inside the boiler is not maintained at the correct level. There are visual level indicators as well as alarm sensors monitoring the water level to check that it is within set safety limits. Whilst we're dealing with boilers, we must mention a unique sensor and alarm circuit known as the flame-out alarm system. A sudden loss of flame inside the boiler can lead to many undesirable consequences. Therefore, optical sensors, flame eyes, provide continuous monitoring of the presence of flame and will give instant warning should the flame go out. The main propulsion engine's alarm and protection devices can be looked at as the most important ones on board ship. On a typical diesel unit, these employ temperature and pressure sensors, which monitor operational conditions to ensure optimum operation and effective lubrication. For example, The temperature sensors check the jacket cooling freshwater outlet, the lube oil inlet, the fuel oil inlet, and the reduction gear lube oil inlet. These are all of primary importance. The pressure sensors monitor the main lube oil inlet, the reduction gear lube oil inlet, the turbocharger lube oil inlet, and the cooling freshwater inlet, among others. These are all part of the main engine's protection system, as well as providing warning signals. Identical systems operate on other diesel engines, such as those driving the generators. Because of their critical function, these sensors must be tested regularly in accordance with the ship's maintenance or test schedules, ensuring accurate function. Only sensors supplied with a valid certificate or assurance of calibration should be installed, and only calibrated test instruments must be used for testing. Here, a temperature sensor is tested at both the minimum and maximum limits of its operation. The quality control is on the measuring device attached to the testing instrument. This one is using an oil bath with a controlled heating device and calibrated thermometer. Details of the test are recorded for future reference. The alarm setting can usually be read from the central monitoring system, provided that it can be demonstrated as operational. This is done by resetting the alarm to a normal value or by simulating an alarm value. But the most convenient method for this test is the use of a test pump and gauge. Here, a lube oil inlet pressure sensor is tested with a precision testing instrument. Testing level alarms sometimes involves activating the alarm manually, in this case a bilge well alarm, and monitoring the response in accordance with the set parameters. The test results should then be recorded for future reference. All these tests are most important to ensure that the monitoring system is reliable at all times. The ship's manual will provide the necessary details for each test applicable to the systems on board. Each engineer on board must know the alarm and protection systems thoroughly, including their relative importance to the ship's proper function. Each time an alarm activates, the duty engineer must be able to answer a number of critical questions. What does that alarm signify? How important is the system to which it relates? what measures must be taken to eliminate the cause of the alarm condition, in what order should the countermeasures be executed. In conclusion, it is essential that you know your ship's alarm system and protection devices, that you pay special attention to the critical alarm circuits on board ship, that you always follow the alarm system's maintenance schedule and ensure that all sensors and display systems are fully functional. When an alarm condition arises, never press the reset without noting the cause of the alarm. If an adjustment must be made to temperature or pressure switches, it is essential that a calibrated instrument is used and direction of change is taken into account. For example, when setting the starting pressure of a compressor, the setting should be the design figure with the pressure dropping. When an adjustment has been made, always repeat the tests at different values. No adjustment should be permitted without checking at least 2 values afterwards. When an automatic restart circuit is involved in machine control, it should always be switched to manual and off before pressing reset, to avoid the machine starting automatically when reset. Equipment should never be restarted or put back into service without rectifying the cause of the alarm trip. Any abnormal run indication should always be investigated, even if the equipment is apparently running smoothly. The engineer on watch must have confidence in the alarm system and protection devices in the engine room. He must be sure at all times that he will be given timely warning of any changing condition which may lead to a breakdown so that he can take remedial action. This confidence is an essential component of good engineering practice.